So good morning everyone. Today let me continue with the fifth lab program, that is News Bayes Classifier, to find the accuracy of the data set. So recently Prakash had covered the same similar concept with the similar program, and he implemented with some other type of concepts. So I'll be concentrating on only of the accuracy. So first of all, before going to Naive Bayes Classifier, let us discuss about what is Bayes Classifier.
Be
Then
louder.
we'll go on
Raza.
with the News Bayes Classifier. Yeah, fine. Go with the Bayes classifier. Let's have a brief introduction about it. Then we'll go on with naive Bayes classifier. That is, we'll see some of the what is actually naive Bayes classifier all about. Then we'll like what are the concepts covered in, and like how the whatever the prerequisite is required for the naive Bayes classifier. Let's discuss about that. Ma'am, 1 second.
Okay.
This is like the overall view of what is Bayes theorem, and already you have studied this. Like ma'am has already taught you all about this, whatever the hypothesis and whatever the concept is been inside the Bayes theorem. She has already gone through all the whole syllabus. So let me give a brief glance, and let's have a like rough view on whatever the Bayes theorem is all about. So for Bayes theorem, the prerequisite whatever is required is called as nothing but the conditional probability. So what is conditional probability? Is you may already know some based upon some conditions. Several equations have been sorted out. So like let me have some. So this equation, whatever you can see, like P of A bar B is equal to P of B bar A dot P of A divided by P of B. So this is nothing but the actual definition or the actual equation of the Bayes theorem. So this relies on the conditional probability. That is nothing but the concept. So how did we got this equation? So like there must be something, an interesting concept, so that we get this, so that we got this type of equation. So what is the structure all about? So consider, for example, if you were like if you want to have the conditions like P of A bar B. So P of A bar B is nothing but, so this is nothing but an hypothesis. So what does it refers? It refers nothing but to one particular event. Like for example, P of A bar B is equal to probability of A, probability of A, given that B has already occurred. Or in other sense, probability or an event A, we have to find that given B has already occurred. So this eventually refers to as a hypothesis. So what I do is I define as P of A bar B is equal to P of A intersection B divided by P of B. So let me have another equation that is nothing but P of B bar A. So this is nothing but an another hypothesis. This refers to probability of B given that event he has already occurred. So this is nothing but a basic definition of a conditional probability. So how do you define this? You define it as nothing but probability of B intersection A divided by probability of A. So let's have some changes over there so that we can get this type of equation. What I do is nothing but I transfer this P of B, I mean I cross multiply to this at the left hand side, and whatever the probability of A which was in the denominator, I cross it to nothing but the left hand side. So what you can see is nothing but you can see here two common things, that is P of probability of A intersection B and probability of B intersection A. What I do is nothing but I equate these two terms. After equating, I get as nothing but probability of A intersection B is equal to probability of A bar B, that is nothing but event A, such that B has already occurred, into probability of B. Probability of B is also an hypothesis, and is equal to probability of B bar A dot probability of A. So let's have, like you can see here, probability of B bar A dot probability of A. We can see that we have already occurred here, and the only one missing term is nothing but probability of B. How do you get is just transfer this, cross multiply this probability of B from the left hand side to the denominator of the right hand side. I just cross multiplied. So after the cross multiplication, we came to know that, so this is nothing but an equation for the Bayes theorem. So for here in Bayes theorem, there are for every concept, like for every hypothesis, that is either it may be uh, any of the hypothesis, you have some of the particular technical terms for it. Like on the left hand side, whatever you have seen, that is called as nothing but a posterior one, and this is nothing but a likelihood, and this is a prior, and this is a marginal. So let me narrate this whole concept and conclude it with a simple example. That is nothing but, let me have a probability of finding king bar face. That is nothing but probability of finding king, that is nothing but phase has already occurred. So either you may have four kings, right, in a particular game of deck of cards. So what I do is nothing but I just reshuffle this. Like here you can see the probability of a bar b is written as probability of b bar a, right? So let me interchange this. So probability of face bar king dot probability of king divided by probability of face. So I have defined this equation in terms of the Bayes theorem. Now you can see here. So this resembles 1 in terms of probability of finding a deck of cards. And you can find here there are nothing but 4 kings out of 52 cards. So what I do is nothing but 4 by 52. And you can find like 12 cards are there which is having some face probability. So it is nothing but 12 bar 52. Okay, so let me have this cross multiplications, and after simplifying I get as nothing but 1 by 3. So what does this 1 by 3 resembles? It resembles like probability of even to 1 such that 3 has already occurred. So this is nothing but the conclusion for the Bayes theorem. So now let me go to the my concept what ma'am has given for me the assignment for the seminar. That is nothing but naive Bayes classifier. So this is nothing but the simple concept which is based upon the conditional probability and along with the Bayes classifier. And as far you have no like Abhilash has already taught you about the Bayesian network. So it resembles some of the concepts and like mixed concepts of all these concepts. So let me have a brief explanation for that, because so that it's easy for you to understand the program. Else what happens if you go to directly jump into the program, you find difficult, you find there's some words technical, whatever the functions I have used in the program, you may find it some difficult. So that's why I'm concentrating on the theory rather than going on with the program part. So let me go on with the simple data set. Like I have a data set of about the fruit, and I have attributes called as nothing but yellow, sweet, long. So you may find here I have three types of fruits, that is nothing but orange, banana, and others. So what is nothing but orange which is yellow I have 350, orange which is sweet I have 450, and orange which is long is 0. Obviously orange will not be long, it is nothing but in a round shape. So that's why I got is nothing but a 0. And overall oranges, like total number of oranges is nothing but 650. It's not like addition of this, it's nothing but total number of oranges which I have is called as nothing but total is nothing but 650. And in banana, I have yellow for 400, banana which is sweet is nothing but 300, banana which is long is also 350. That is obviously banana cannot be round, it is already, it's always in a long shape. So you may find like I have the data set, I have the value as 350. I mean, this is a record. And you may find like banana, the total number of banana present with me is nothing but the 400. And others may be except banana and orange, you may find any other of the fruits which is nothing mixed one I have, which is yellow is nothing but 50, and which is sweet is nothing but 100, and long is nothing but 50, and the total number of the other fruits which I have in my hand is nothing but 150. The total number of this is nothing but 800, 850, 400, and you find like 1200. So what I do is nothing but I need to find, like, see, this is the equation of the Bayes theorem as we have already discussed in the previous slide. That is nothing but probability of hypothesis of a by b is equal to hypothesis of b bar a dot hypothesis of a divided by hypothesis of b. You may either in terms you can call it as probability. So now I need to find out the probability of, like, you can't visible it, but yeah, you can understand it, right? Yeah, yeah, fine. So you may find like probability of yellow bar orange, that is nothing but probability of a fruit which is nothing but yellow, which is, and it is orange. So what I do is nothing but consider this as nothing but a and this as b. What I do is nothing but I reshuffle it, it becomes probability of orange bar yellow. Like I have reshuffled this, and you can find like probability, the first one which is there you need to be put in the numerator, and the second one needs to be put in the denominator as per the equation which we have derived from the conditional probability. So what I do is nothing but probability of orange bar yellow. You may find like orange which is yellow is nothing but 350. So you write it as nothing but 350, and you can divide it by 800 because the total is 800. And you can find a probability of yellow. Probability of yellow is nothing but 800 out of 1200, right? So what I do is nothing but 800 by 1200. Then probability of orange, which is nothing but 650 divided by 1200. After simplification, I got it as 0.5. You can do the similar method for finding like probability of a sweet bar orange. You can do the similar method, and I got it as nothing but 0.69. And after finding the another probability, that is nothing but probability of long divided by orange, we got is nothing but 0, because obviously you have one term as 0, so definitely the answer must be 0. Then you can find it's nothing but probability of a fruit bar orange, you can find a fruit by banana. So now So you can see here probability of fruit bar orange, probability of fruit bar orange. But in previous instances, we find out probability of yellow bar orange, probability of sweet bar orange. But what to do if you have like probability of fruit bar orange? You need to consider the whole record. So how did I got the answer as 0? Because the one term was 0 and I got 0.53 from the previous one, 0.69 from the probability of finding sweet bar orange, and from probability finding long bar orange is nothing but obviously 0. So if one term is 0, then the whole term is 0. So the similar mechanism for finding the other rest with this. Moving on with the second concept, like that is nothing but naive based easy example from my middle school student girl. It was not by me. It was done by this is a research done by the other one. So yeah, fine. So let me have this yeah, fine. Let me go on with this simple example that is nothing but a tennis example. You may find nothing. We have set of 14 records, and we have some negative records and some of the positive records. So positive is highlighted by the red and negative is highlighted by the black. So after like you can find here you have 14 records and you can find here P of play is equal to yes we have 9 records out of 14. You have P of play that is equal to no that is nothing but 5 by 14. And you can find here like for outlook you can find wherever you can find sunny, overcast and rain. Like you have only three records, either it may be sunny or it may be rainy or it may be overcast. And if it is yes you have 2 by 9, and if it is no 3 by 5, the similar method can be applied here. And if for the similar for the temperature, similar for the humidity and similar for the wind. And it's obvious, you can understand how did you got 3 by 9, 4 by 5, 6 by 9, no need of explanation. So fine, let us go on with this so now let us go on with the execution part because of the time complexity. Let us go on with the execution part. Yeah, fine. So this is nothing but the program that needs to be implemented, and the question is like write a program to implement the new Bayesian classifier for a sample training data set, stored as a .csv file, compute the accuracy of the classifier considering few data sets. So what I do is nothing but I start the program with the importing of the packages and some of the other built-in libraries which is available in the Python. So what I do is nothing but I import pandas as PD, as you all know, and from SQL and imported. This is all for the event functions for event handling, and similar from SQL and pre-processing, import, label, encoders. These all are for event handling concepts. Whatever like for whatever the functions which will be used in the future instances, the similar is been defined in the irrespective of the background. So what I do is nothing but I load the data set as a .csv file. That is nothing but you know how I have explained already how to load the data set. Data set is already loaded as pd.read csv file. So and you need to give the file name, and after that let me like I have 14 records, but I use only the 5 records because going on with the 14 records is nothing but the time complexity issue. So I use only the 5 values of the data sets. I use that the first value of 5 values of the data.head. Data.head is nothing but to read the first values, and you can find here outlook, temperature, humidity. This is nothing but the attributes of the data set, and can find like I have considered these first 5 records in which 3 are positive and 2 are negative. Coming back to the future concepts, like the further implementation part is as x is equal to data dot I location of -1, except the last attribute or the column. The rest all the part will be printed over here. That is nothing but the output of the program will be like the first 5 values of the train data is outlook, temperature, humidity and windy. That is sunny, overcast, rainy, and you all know except the last column every part is been printed. Now next let me have another variable that is nothing but avoid and data allocation of -1. As you all know, like I have not used double semicolon 2 times because semicolon 2 times is used for some more number of the columns to be printed in the execution terminal. But I use only a single colon, so only the last part is printed. That is nothing but no, yes, based upon which we simplify the program. So now let us have the coming back to the next part. That is nothing but I use a variable like that is called le underscore outlook. That is nothing but label encoder. Encoder, as you all know, we use either like we use for the encoding concepts, and we have another variable that is x dot outlook is equal to le dot outlook. That is nothing but the previous whatever we have the encoding part in the first instance that needs to be fit transform. That is x dot outlook. Fit transform is used for the transforming from a particular instance to a particular instance, where we have some of the variations in the data sets. So next we have le underscore humidity. That is nothing but you can find here the similar functions is being used, and we have four attributes in the x variable. You can find we have the four in the x variables. You can find outlook, temperature, humidity, and windy as the output. So you can find I have used outlook, temperature, humidity, and windy. Okay, so similar functions, similar instance, similar functions to be implemented. And transformation is from the instance, from a transformation is nothing but a particular instance that needs to be converted based upon some particular data. Now let me train the data. Train the data is nothing but let me have a training of the data of the first five records. So after the training of my data, I find it as outlook, temperature, humidity, and windy, and it got encoded, and I got the result as 220111120, and it has some of the uh, um, it undergoes some of the back principles and all, like some of the concepts which even I'm not thorough with it. So let me go on with the y variable, that is nothing but le underscore play tennis, that is equal to label encoder. Y is equal to le play tennis fit transform of y. So this is nothing but the last column that needs to be trained, and and you got the output as 0 1 1. Why you got this output is nothing but you are using 14 variables, sorry, 14 records, and you have used 5 records. And finally the last part of the execution is nothing but you need to find some of the event functions over here. I have four variables, that is xtrain, xtest, ytrain, and ytest. This is nothing but training the x values and training the y values. And what I do is nothing but I split over here based upon the size 0.20, because I need to find out the accuracy of the data set. And finally I go with the classifier is equal to Gaussian NB. And what I do is nothing but I feed the data, that is nothing but xtrain and ytrain, then I compute the accuracy. And for particular this data set, my accuracy is as 0.66666. So these are nothing but so I wind up my session. Thank you.